talk today about an example of mechanical example in which we have a wrench and a bolt, and we wanted to apply a force on this wrench and then go through the process of structural analysis using COMSOL. So before we go there, I wanted just to kind of remind you of the different elements in the interface with COMSOL and how we're going to select the model. We will start the selection from a built-in file that exists in COMSOL so that we don't have to spend the time in doing the geometry, and we will just do the physics and the whole process of the simulation. So if you look here, we have the windows in COMSOL. You have the different, the primary node is the name of the file itself, which is the trunk, and then we have the additional nodes that come, the global definitions, and then the node that describes the model itself, and then a node that describes the study that we're going to do in the model, and finally the node that describes the results. If we expand the node that describes the model, then we see that we have a child, what they call child nodes, and the child nodes, they start with the definitions that are local, not global. The global definitions, such as parameters that are used everywhere in the entire model, we're going to put them into the global definitions node, as we'll see in this example. However, if we have specific definitions of parameters that can be used in the model and then forgotten after we exit from that model, then we can redefine them in the child node of the model. So if you look at the model node, it has the following child nodes. It has the definitions, and then a geometry that you can either build in COMSOL or import from external file, such as a CAD file or even a prior COMSOL geometry file that you have generated. And then in addition to this, we have a materials child node that we will define. Material, we can use it from, we can select it from a library, or we can define it ourselves. We can define the properties ourselves. We have also the physics that we will study. Here it says acoustics, but we are going to study solid mechanics. And then finally, the last child node is called mesh, in which we're going to define how coarse or fine the mesh is for better resolution of the results. Then the next node is the study node, and the study node we will select either a time-dependent or a stationary, which is static, a steady state, or other forms such as frequency, domain analysis, or other analyses. But here in the next example that I'll show you is going to be a stationary problem. There is no dynamics, there's no time dependence in it. And then after we determine the study and decide on the parameters that describe the study, then we will get the results and then display the results. And as we display the results, we have to select from a very wide range of display modes. We can create a group, for example, either in the form of tables, or we can select plots. So the plots that we have, we can select either 3D or 2D plots or 1D plots. And finally, we can export the data into files that are ready for distribution and reporting right away. So that's kind of the general interface, and all of this is under the Model Builder panel. Then we have another panel that has three functions. This panel has a model library in which you can select from a library of existing models that people have built over the years, and these are going to be updated all the time. So we will have more models available, and it gives us also another tab that gives us the settings for any of the steps that we determine. So as we will see, by right-clicking on the right-hand side here on any of the nodes, it gives us properties and settings. And these properties and settings, we will find them in a tab, a tab here, and the tab will give you ability to either put expressions or parameters or values depending on the particular function of this child node that we're studying. And I wanted to also to point out that we will be visualizing all of the data in the graphics window, and in this graphics window there's a number of tools that will allow us to move the object, rotate it or expand it, and so forth. Finally, there is a dynamic help here. Dynamic help is a special panel on the right hand side, and the special panel can give you immediate help on any of the topics that you would have within the model. So with this, I think we have a pretty good idea about what we wanted to look at and study. And to summarize, you can see here on the nodes that we have built. For example, if we have a bus bar will be the name of a model that describes the physics of bus bar, which is heating, joule heating, and the thermal stresses combined together. Then you define some parameters for that model, and then you go into the child nodes of the model so that you can have the specific definitions of certain parameters, select the geometry from outside or you build it yourself, select the material, and then select the physics. The physics is joule heating, and then if you expand, you right click on joule heating, you'll find also these child nodes, and the child nodes come in to determine the boundary conditions or initial conditions in the system. If the boundary conditions or initial conditions are default, then you see that the D is right here, expanded here. So in the D indicates a default. And you can override the default by right-clicking on the boundary condition and changing it to the appropriate value that you want. Finally, we have once we decide on the physics, the mesh, we can either do it manually by ourselves, or we do it that's called physics-based, in which we allow COMSOL to do the job for us once we specify how fine or coarse the mesh is. And then finally, we get the results, as I mentioned before, in the form of tables, plots of various sorts, and we export it. So with this, we're going to be ready now to go through a real process here in which we're going to study the deformation of this of a deformation and the forces and the stresses on a wrench. So I'm going to just get this out of the way and close this window here, and then look for what we're going to do here. So if you see, when I start on the right hand side here, I have the global definitions, and it's an untitled. So if I click on it and then right click, then I can add a model immediately that I can define as the wrench. You can add a model either if you look at this tab here. This tab, it shows you that it can be new, so you can add the model through this tab, or by right clicking on the untitled, or from the top level, if you just click on file and then you click on new, then you add the file. So these are three different options. So let's just click on the tab here. Then it gives us now a root directory that is untitled, and it has only global definitions and the results node. So we go now to the tab, the model wizard window, and the first step is to select the dimension of the study, 3D or 2D or 1D. So we're going to select 3D, and then we click the next arrow is right here, and then we, at this point, we need to decide what kind of physics we will study for this 3D model. And what we want to study is the solid mechanics. It's like part of structural mechanics. It's called solid mechanics, in which the solid is broken into tetrahedral elements, and we determine the stresses and the strains in all of these elements. So if we click on solid mechanics and right click on here, we can add the selected solid mechanics. And so if you just you can see I added it twice, so I have to remove the selected solid mechanics 2. So it shows that the added physics here, solid mechanics, and the variables are the displacement field, which is the displacement in the x direction is called u, in the y direction is called v, and in the z direction is called w. So I added that, and then I click next. Then the next step is to determine whether I'm going to have a time-dependent study or a stationary study. So I'm going to click here, stationary, and then I'm done. So when I'm done, I click on this flag, which is the finish flag, and that essentially is going to go through the process. And you can see on the left-hand side here that 2 additional nodes have been inserted. The model node here, which you can contract or expand by clicking on the arrow, and the study node, which we can contract or expand. So if we contract all the nodes, I have now the 4 nodes, the definitions, the model one, the study, and the results. So now I'm going to go to the model node here, and I want to get the geometry. So I wanted to go to the geometry and define it. So if I click on the geometry in here, then I want to have import a file. So if I right click on geometry, it shows me a number of possibilities, either that I build the geometry myself with blocks, cones, cylinders, more primitives like lines and helices and polygons and so forth, or if I have already the geometry somewhere, then I can import it. So I'm going to click on import here, and then it's going to open in the settings tab, which is in the wizard window. And this settings tab, it says, what do you want to import? So do I import any importable file, or a COMSOL multiphysics file, which comes from the library that is built in, or a 3D CAD file? So let's select COMSOL multiphysics file. Then I need to know the name of that file. And since I don't know the name or where it is exactly in my directory, then I'm going to browse. And when I browse, I go to my Mac window here, and my Mac window can help me actually find the file. The file is called wrench. So if I just type here wrench, W-R-E-N, wrench, then I see right away on the top here, because I wanted to have wrench.mph, which is multiphysics, mph. Then I click return. Then it shows me today I was playing with it, or I can get it from an earlier location. So I'm going to choose this one here and open this file, and then I'm going to have to click import so that it will bring the file to the front. And right now you can see it showed me the wrench. You have a wrench here and you have a bolt, and the study is that we're going to put a force, downward force on the wrench of 150 newtons, and the bolt, we want to fix it. So we want to fix that bolt so we don't allow it to move, and then we will see a stress distribution in the entire wrench. So before we go, I want to just explain how you move things around in the graphics window. If you left click, then you can rotate, as you can see here. So I can rotate in any direction I want. If I want to bring it to the default view, you have this tab here, and the tab shows the 3-coordinate system. You just click on it, then it goes back to where it came from. If you right click now, I can move the whole thing out, in and out of the window. So this is right click. If you have a good mouse that has a wheel in the middle, then by rolling the wheel you can actually zoom in and zoom out. I don't have that, so I can use another facility. There is a tab here that's called zoom in, so I can zoom in. Now the thing is just went out of sight. Then I can drag it here. If I drag it, then I can just study the feature as it is moving, or rotate it and look at the different surfaces. Now I'm going to bring it back to where it was, and then I wanted to show you that you can also have projection views like XY view, like if you click on the XY, or you can have a YZ view, or you can have a ZX view. So having done that, then we can now select certain domains. Now this whole object comes into the window, and it's made of lines and domain and surfaces and volumes. And for various reasons, we are going to choose surfaces to put boundary conditions on it, such as a force. We can choose volumes to put additional physics into it in the future, and so on. So how do we do that? There are a number of tabs here to select the domains. So there's a tab select domain. So if I click here, then I selected actually the domain. One domain is the entire wrench. Another domain would be just the bolt. So I have two domains, domain 1, domain 2. Now I can select a portion of a domain by saying I can select here. If you look at the next tab over, it selects boundaries. So if I want to select this boundary, so this is the surface of the bolt on that side, which I really don't need, but as you will see later, I need to fix the bolt on the other side. So in order for me to do that, I have to rotate, and then if I select that, then it shows me where I want to fix that surface here. Okay, we'll come back to that later. I can also be more specific by selecting a line, like a line here. So if I can click on, let's say, this line here, I can put in additional force on a particular boundary, or I can put maybe a moment or a force or any other description on particular lines. And not only that, but I can also select points. I might want to select one point, for example, here, and just fix it so it doesn't move anywhere. Then the rest of the model can move everywhere except for that particular point. So these are all different possibilities, and allow us the viewer and the graphics window allow us to make all of these changes as we move on. There's a tab here that brings back, okay, so we have here brings the viewing back to where it was. And then we're done actually with all of the selection process. So if we're done with the selection, we want to just okay, so here we escape. If we just run into trouble, escape with that, and we are done. So now we're back to where we were. So right now we have the geometry. I want now to contract the geometry node because I'm done with it, so it doesn't bother me anymore. Now I want to select a material, and the material I can build in the properties myself, or I can select it from the database that COMSOL has. So if I click on materials here, and it shows me in the model builder wizard a table, and the table has nothing. So if I right click on material, then I can add a material myself, or I can open the material browser, which is the material browser that they have inside COMSOL. And the browser has a number of materials, recent materials, a library built in, and also other materials for different types of physics. So let's go to the built-in. You have an arrow here. If you click it, then it shows you what's built in. So we want to take a steel, a simple structural steel, and right here you see a structural steel, and then if I just want to add it, there's an add button on top here, or tab. Then I click on it, then it should add the properties of the structural steel. Notice that the material properties here is a table that has things like the density, the elastic modulus of the material, the thermal conductivity, because a lot of times we want to do thermal analysis with the stress analysis, so you need the thermal conductivity and the specific heat. So these are the basic parameters that are used in this particular model. If we go into more sophisticated modeling, a lot of times we build material models that we can input into by ourselves into the library, and then we can use it in the future. The other thing that I wanted to indicate that you note here that we selected all domains here, which means that we have two domains. Like if you just click on the domain 1, it's the green, and domain 2 is the green here. It shows you the selection, which means that the material we chose applies to these two domains. In other situations, I might have two materials. For example, for domain 1, I may want to have structural steel. For domain 2, I might want to have like an aluminum bolt for some reason, odd reason, but that could be done. Here they are the same. So now I selected the material, so I'm done with this material tab. I'm going to contract it, so I'm done with it. And now I'm going to specify what type of calculation on solid mechanics that I want to have. Well, I haven't really specified. I want to put a force on this surface here, and I want to fix this end condition. So to put a force here, I must define a parameter that represents this force. So let's go first to global definitions, and then we go to right click and then define a parameter. So the parameter here comes with the table, and the table has a name, expression, and a value. So the name here, we can put F, for example. F is here. And the expression is, what is F? It could be constant, or it could be a function of something else, some other parameter. Here, let's say it's a constant, it's 150. So if I write it 150 here, then I have a force of 150, and it shows me 150, and I can describe it. I can describe it, let's say applied force, so that I remember what it is. Now, this is not so good because I didn't specify the units of what I'm putting here, and it's very important to pay attention to the units, because it shows here down here that you have a name is F and the expression is 150, but it doesn't say what it is. So the units is kind of peculiar in console. What they do is you have to use the square brackets, and put the unit inside the bracket and close the bracket. So in this case, you will see that the unit value says 150 N. N is for Newton. That's the unit for force. And I have now the unit for force, and I'm done with that parameter, and the global definitions is done. And now we are ready to specify the boundary conditions that we want in the solid mechanics. So now we go to the solid mechanics and then right click. Okay, before I do that, if you look at the solid mechanics, the child nodes are three: linear elastic material, so the material is deforming elastically, and it has a default boundary condition that all of the boundaries of this model are free to move in any direction. You're not constraining them. And initial values if we have a time-dependent problem, but here we don't have a time-dependent problem. So obviously that's not going to work, because we want to leave everything free except for one boundary here, which is this one on this surface here, that we want to fix, and then we want to put a force on the other side. So in order for us to do that, then we just have to go to the solid mechanics again, the physics, right click, then it will show us a huge number of boundary conditions, and also material models. Like you can change it from linear elastic to linear hyperelastic material, and so on. So now we just want the boundary conditions is like boundary conditions here, and we want to have a fixed constraint on one side. So if we just click fixed constraint, then it opens up the tab for us for fixed constraint. And now we want to select manually the particular boundary. So I have to go now to the window and then select one of the boundary. So selection is two steps. First you left click, then it shows you the boundary in red, and then you right click, then it shows you in blue, and it will select it to you, and it shows it. It will show it into the Model Wizard panel as boundary or domain number 35. So that's selected, and it's selected as fixed constraint. Now we've done with that, so we can bring it back to original shape, and then go to solid mechanics. We want to do something else. We want to put a force, and the force is going to be on only like one side here. So I have to right click and